All right, so today we're going to be solving equations with variables on both sides. You already know how to solve equations. We've done this last year. We're just going to kick it up one little notch, and I'll show you that as we go along. The first thing we need to know is there's like one big main theme that will help you with solving the equations. That big idea is we want to get variables to one side and we want our numbers or our constants to the other. This will help us set up our problem so that way we can isolate our variable to find our answer. And if you remember, constants is just the vocabulary term for a plain old number. Constants are our numbers. Variables are usually our letters. So we want variables to one side, constants to the other. There are 4 steps that we'll use to solve equations. Step number 1. Remember how in our assignment yesterday where we had to fix the problem by using distribution? We had to distribute the number outside the parentheses. Well, we might have to fix these problems and do the same thing. So the first step is to use the distributive property if needed. So we're going to check, make sure we don't have any of those parentheses that we need to distribute out. All right, step 2. We're also going to check to see if we can combine like terms. Combine like terms if they are on the same side. So if they're on the same side of the equation, and we need to, we will combine like terms. Step 3. We're going to move the variable to one side. And we're going to do that by using inverse operations. So move the variable to one side by using inverse operations. Inverse operations, keywords from last year. Does anybody remember what inverse means? Opposite, yes. So if I asked you what is the inverse of addition, you would say subtraction. The inverse of division, multiplication. All right. So when we're moving our variables with inverses, this is where we're going to do our addition and subtraction inverses. So that falls in line with this big idea up here. We got our variables to one side. So what do you think is going to be our next step? Getting our numbers, our constants, to the other side. So step 4, move the constants to the other side by using inverse operation. Move constants to the other side by using inverse operations. And that's still going to be just with our addition and subtraction inverses. That's all we're going to need. And the last and final step, is going to be to isolate the variable. What does that mean, isolate the variable? Get it by itself. Isolate means you're all alone. We're going to isolate the variable by using inverse operations. The difference is this time, when we're isolating, is when we'll use our inverses of multiplication and division. And after you finish step 5, shake out your hand. I know that was a lot of writing. All right, good job. Now we're ready to move into our example. Can I move up to here? Okay, example number 1. We're going to start out with 13x plus 9 equals 6x minus 12. All right, let's look back to step 1. Do I need to do any distributing? Do I have any parentheses I need to fix? Nope, so we can go to step 2. Combine like terms if they're on the same side. Well, what they mean is if I have this equal sign and I divide it, if I look at just this side, do I have anything I need to combine? Nope, because I can't combine x's with numbers. On this side, do I have anything I need to combine? Nope, so we're on to step 3. Move the variables to one side by using inverse. Which side? It doesn't matter. But I'm going to tell you there's an easier side, usually. What you want to do to make your problems a little bit easier to work out is on your variables, wherever you have more variables, keep it on that side. So when I look here, I have 13 x's on the left, 6 x's on the right. Where do I have more? So we're going to keep them on the left side. Okay, it just makes our problem a little bit easier so we don't have to deal with negative variables as much. All right, so I need to move this 6x. Well, the first thing I need to do is, since we're switching sides, I need to draw this line down the equal sign. We need to separate our left and right sides of the problem. I expect when you work out these problems on your papers, I expect as part of your work shown to see the line, and I expect you to see all the steps that we're fixing to do. Okay? Keep your work neat and organized so you don't get lost in your process. All right, so I need to move this 6x. Well, is this 6x positives or negatives? They're positive. So what's the opposite of positive? Negative, or subtracting. So I'm going to subtract 6x. What you do to one side, you do to the other. But I'm not just going to write it anywhere. I'm going to be organized. I'm going to write my subtract 6x underneath my x's. Keep them organized. Now, on the right side, 6x minus 6x, that cancels. All I'm left with is my negative 12. I'm going to bring down my equal sign. I have my positive 9 I can bring down. But now I need to combine these. 13x minus 6x. 13 xylophones.
7x.
Take away 6 xylophones. Yes, 7x, or 7 xylophones. Now you're just at a 7th grade problem right now. So we just kicked it up one extra step by putting the variables on both sides. Okay, now that I have my variables over here on the left, I need to move this constant, this plus 9, over to the right side. So what's the opposite of adding 9? Subtracting 9. But what I do to one side?
Come to the other.
Do it to the other. What I do to one side?
You do it to the other.
Do it to the other. Very good. So Positive 9, negative 9 cancel out. I'm left with 7x is equal to,
I'm saying.
I have negative 12, and I have negative 9. When I combine those, I have negative 21. Integer rules. Negative 12 minus 9. Add the opposite. I'm really adding 12 negatives, and I'm adding 9 more negatives, so I have a total of 21 negatives. Remember our integer rules. Same signs, add and keep the sign. If the signs were different, like up here, we would subtract and keep the sign of the larger number. You've got to know your integer rules. All right, now we're ready for step 5. Isolate the variable. I need to get x all by itself. How do I do that? What is the opposite? This says 7 times x. So what is the opposite of multiplying by 7? Divide by 7. But what I do to one side, do it to the other. 7 divided by 7 is just 1x. Negative 21 divided by 7. Negative 3. Don't forget your sign. So the value of x is equal to negative 3. All right, let's do another example. Example number 2. Negative 11x plus 9 is equal to negative 2x plus 45. All right, what do I check first for step 1? Use distributive property. Do I have any parentheses I need to get rid of? Nope. Step 2, combine like terms. Do I have anything to combine?
No.
Do I have anything to combine?
No.
Nope. We don't have to fix it. Now we're step 3. Variables to one side. Well, I got to split it up so I know I've got 2 different sides. Now, when I look at my variables, this is tricky. Which side has more value? Negative 11 or negative 2? Good job. Because negatives are like backwards. They're like opposite. The bigger the negative, the smaller the value. So negative 2 has a greater value. So we're going to bring all our x's over here. So I need to do the opposite of negative 11x. Well, what's the opposite of negative 11x? Positive, or adding 11x's. But what I do to one side?
Do to the other.
Do to the other. These cancel out. I can bring down my positive 9 equals. And I know it seems really tedious, but bring down your equal sign. It lets you know that this is a whole row of an equation. Okay? Now, negative 2 plus 11. How many x's do I have? Positive 9x. Signs are different, so I subtract. 11 minus 2 is 9. Take the sign of the larger. My 11 is positive. And then I can bring down my plus 45. All right, now we're at a 7th grade problem. Review from last year. How do I move the 45? Or do I need to move the 9? Which one am I moving? Okay, so if I move my 9 over here, then I have variables on the side and numbers on the same side. What did we say? We wanted variables on one side, numbers on the other. So I need to move my 45. So how do I get rid of adding 45? Subtracting 45. I know it would look nice and pretty if we got rid of that 9. That whole side is clean. But then I don't have variables on one side, numbers on the other. Okay? So 45 and 45 negatives cancel. Here I'm left with 9x is equal to 9 minus 45. Got it. Negative 36. We're ready to isolate. I can get the x all by itself. What do I have to do? This says 9 times x, so the opposite of multiplication is division. Divide by 9, but what I do to one side?
2 to the other.
2 to the other. 9 divided by 9 is 1, so I have 1x is equal to -4. Final answer. Yes, I will expect to see this much work for each problem. Okay, you've got to show your work. Math is more about just finding the answer. It's about the process. It's about the problem solving, going through the steps, analyzing the numbers, okay? Analyzing the inverse operations. Good job, guys.